Hello, everybody. My name is Zach Probst. As mentioned, I'm a software engineer at Intuit, and I'm also relevant to this, the maintainer of an open source project called Nodestream. And the title of this talk being about evolving your database. In the world of graph databases, there's lots of different tools for ingestion and creation of data in your graph. But a lot of them seem to kind of stop at day one. At least that's my observation. And the title of this talk being about evolving your databases as you progressively build out your pipelines and add new data and change your graph. Um, you need something that walks along with you and helps you build changes into your database as you make them in your data pipelines. And so Nodestream itself is really focused on managing and facilitating that data ingestion process for you. And what we're going to be demoing and diving deep into is the migration features, which are that evolution process. Um, this can be pretty interactive if you want. I have the code that I'm going to be using in this demo in this repo here. I think I can even, maybe I can even post the link. I'll try that, see how it goes. Right. So there's that link to the repository. And let me get back over here. And this is essentially what I'm going to be doing is just walking through this particular process. So if you want to go through it with me, you absolutely can. I also have my eye on the questions as well. So we're going to go ahead and get through this. If you need to set up a Nodestream, you can follow this example here. You also need a local database, so you can install that. I have a snippet for Docker you can use. You can install Neo4j Desktop or however you want to do it. And our goal is going to be basically to build out a social network kind of graph, piece by piece. So our first phase that we're going to look at is just kind of building little person-to-person relationships for somebody who knows somebody else. And then we're going to add some data onto those nodes. And then we're going to create another relationship to some sort of location node. And then we'll change some of the attributes around. And we'll see how Nodestream helps you evolve that over time. If you want to follow, here's the main Nodestream repo. It goes in a lot more depth about all the different features and gizmos that Nodestream has. There's a whole bunch of talks from us here, including my previous 2 rounds here at Nodes, and everything else you might need to get started with Nodestream. But you can follow this basic example tutorial that we're doing here. Everything is fairly documented. Of course, you have me walking through it too to refer back to once the videos get posted. But without further ado, let's go ahead and hop right in. So here's a Visual Studio Code window that has that repository I was just showing. There are 3 data files in here, which is just some fake raw data that we have. This is what we're going to be building our graph out of. The diagrams, just those images I just walked through, and then the individual Nodestream pipelines that make up the different parts of that graph. I will walk through each one of those as we kind of take our phases through this. And then the nodestream.yaml file, which is essentially our sort of project file, if you will. You'll see that I have only one of these pipelines defined in here. The other 2 are commented out. I'll get back to that in a minute. And I've also defined a Neo4j database targeting my local environment that we'll be interacting with for this demonstration. So let me go ahead and pop into this social pipeline. And I'll remind you that that is just intended to do, it's not loading in here, just intended to do this basic person-to-person relationship here, right? All we're going to be building is this graph with this first pipeline. So if we take a look at it, what we're doing is we're pulling in this social.csv data, which looks a little bit like this. And one thing to note about the way Nodestream works is it kind of puts you in this mental model that all data can be kind of fuzzed as if it was JSON. So in this example, this CSV data kind of maps to this equivalent JSON record here. And that'll come relevant in a second, but this is kind of the way that Nodestream treats data as it goes through the system as JSON-like. It doesn't literally have to be, it doesn't get converted into it, but it kind of gets treated as if it is. And so the main magic in Nodestream itself is that it is schema aware, and that's a big part of what makes this possible. And so as you work with Nodestream, you'll find out that there's this kind of common pattern of taking data and then mapping it into nodes and relationships. We call that interpreting. And so in this case, we're defining two interpretations in our data. The first is that there's some source node that we're referring to, and that's kind of this IDA field. And then that we're also going to create a relationship to another person node, which we've used this IDB field. They both share the same node type person, and we're defining a relationship type of nodes. With this relationship, we don't have to create the nodes first and then create the relationships. If the other node doesn't exist, it'll create it automatically, at least in the configuration we have here. So that's what's going to happen when we run this pipeline. But before we get there, we're going to create a migration to set up our database. So let me hop over to the terminal. Nodestream has a CLI tool to do a lot of the basic day-to-day tasks as part of it. So in this case, what we're going to do is we're going to run Nodestream migrations make. Now what this is going to do is it's going to take a look at our project's schema and then build a series of operations necessary to change the database schema to match what our pipelines say the schema should be. So it's easier to see once I actually run it. So I'll hit enter here. And it'll take a second. It's going to look through the schema. And it'll put out a summary of the set of changes it wants to make to the database. So first, it wants to create a node type called person. Nodestream automatically indexes this last ingested at field on all data types because there's a TTL feature. It's a little bit out of scope for this, but so it wants to put an index on that last ingested at field. It wants to create a relationship type called knows, and again, put an index on that last ingested at field. And you'll see that it says migration was written to migration / and then like the date and time.yaml. It also gives you a hint that you should run Nodestream migrations run to apply that migration. But let's first take a peek at what the migration anatomy is. You'll see because everything is kind of declarative in Nodestream, that the migration is just defined as another YAML file. And here is essentially the programmatic description of exactly what I just walked you through. Here is each one of those individual operations that it's going to do to the database. So let's see what actually happens in Neo4j when we run this. So I will do Nodestream migrations run, and I have to specify what database I want to target because I can have as many databases as I want as part of the project. So I'm just going to refer back to the Nodestream.yaml file and see that I called the test target I have here my DD. So I will do exactly that. You'll see this takes a second, and then it says it was successfully executed. So let's just take a quick peek at the database. First thing you'll notice is if I run a simple query, there's only one node in here, and that's the migration node itself. Nodestream retains what migrations it's applied as nodes in the database. But you'll see that there's no data here, so we haven't actually ingested anything yet. We just prepared the schema. And we can confirm that if we run something like show constraints. You'll see that in this case, it's created a uniqueness constraint on the ID field for the person node. This is going to help with ingestion speed, but it also makes sure that everything is correctly constrained for what we defined as the key of that person node. And same thing too, I can show you those indexes that were created for the last ingested app timestamp. So all we've done so far is just some basic schema preparation. If I go ahead and run that social pipeline, and again, I'll specify the target as my database, and it'll just take 1 second to run. Now, if I rerun our nodes command here, you'll see that we actually do have a little subgraph of stuff. And this graph isn't particularly interesting. There's not a lot of properties on here, but we do have the ID field, and we also have some metadata that Nodestream automatically adds to all nodes, including basically what pipeline was ingesting that data and when it was last ingested. But we don't have a lot of rich properties. We didn't add names and birthdays and all that kind of stuff. We'll get there in a second. But that's our day one experience. We build our little graph, and as it turns out, we need to add more data, right? So what do we do? Well, let's go ahead and take a look at our second pipeline and see what's in here. So that's our people pipeline. And if we take a quick peek at it, again, we're pulling from another CSV file. This can be a variety of different data sources. Nodestream has a bunch that are built in, and you can create your own. But we're just going to stick with CSVs for this. It's reliable. In this case here, we actually are enriching some sort of data out of our person database somewhere, and we're adding in name and age properties. And again, as a reminder, that kind of gets fuzzed as JSON. And so when we're mapping our node, we're going to, again, we're going to query into that JSON, in quotes, data for our properties that we're interested in. And here we're not creating any relationships. We're not doing anything fancy. We're just updating nodes. So we have our source node interpretation again for our person. We get the person ID field from the person ID column, and then we add our name and age properties. Also, I've added an additional index on name. We might want to query for that in our data fairly frequently, so I added an index here. So I will double check that I uncommented that. I did. So this pipeline is now part of the project. And so if I run Nodestream migrations make again, you'll summarize for us that it's found 3 changes to the schema from our last migration. First, that we added an age property, a name property, and we indexed that name field on the person node. So that's pretty cool, right? I'll go ahead and run that again. Actually, let me take a peek at it for you first. You'll see here that, again, is the same declarative description of those changes that were summarized to us. Here, we can change things a little bit. Let's say we wanted to set a default value for age. Instead of setting it to be null, we could set it to be -1 or whatever. I'll just leave it as null for now. But certain migration operations actually allow you to change them in order to change the behavior slightly for whatever suits your needs. So we'll do run again, and we'll do target my DB once more. And then I'll take a second, and it was really, really quick, but you only see that it ran through one migration, which was that last one, because it looked back at those nodes that I showed you before, and it found that it already ran the first migration, so it didn't need to rerun it. It just ran the second one. And as far as schema is concerned, we don't have any, since we left it be null, we don't have any name or age properties right now, but we should be able to see this index field that was created. So if I pop back to our database and do show indexes once more, you'll see now there was extra record added for this, where is it here? The name field additional index. So we evolved our schema. Let's add a little bit more data into it, and I'll pop to our third pipeline. I'll uncomment it again. That's adding it to the project in this case. And if we take a peek at it, same deal. CSV file gets treated as JSON. In this case, we're adding where people live or live in this case. So where they are, what city they're in. And this is, of course, very a vague interpretation of location, but it'll work for this demo. Again, we're going to key off of the person node here, and we're going to get that ID field. And then we're going to create a relationship to a location node, a new node type, and a new relationship type called lives in. And that name we'll just also use ID for that, and we'll get that location field. So let's go ahead and do our migration one more time. Run target my database, and we will see that we again the same thing. It didn't do any changes here because I already ran it. So if we hop to our database one more time, you'll see here's that nose property. And I didn't save this. That's what went wrong. I gotta do a migration. Getting ahead of myself. Migrations make to detect those changes to our schema. And here it is. That's the summary I was looking for. So we're going to create a new node type called location. We're going to index, ingest that timestamp on there. We're going to create a relationship type and index that, and that's a new migration. Now I can run that migration against our database. And we'll see, it took a sec. Now if we refresh this, there's a handful of new indexes in our schema. There's the one for lives in, and here's for location as well. And if we pop down to our constraints, we'll see location. And again, that's a uniqueness constraint because that's like the key of the node. Now let's go ahead and just kind of catch up, right? So I've just been changing our schema, and I intentionally didn't run that last pipeline because the schema and the data is actually somewhat decoupled. So now let's go ahead and run those last two pipelines we created and see that that data is as we matched it. So I'm going to do a Nodestream run, and then I'm going to type in people for our people pipeline, and I'm also going to type in locations for the locations pipeline. I'll run them both at the same time, and I'll do target my database. So you'll see those ran really, really quickly. And if we refresh our graph, first we'll see that there's some more migration nodes applied, but our main graph is a little bit more interesting. We have locations, multiple people live in the same location, people know each other, and if we take a peek at these nodes, we have age and a whole lot more metadata about the different pipelines that contributed to this node. And as well, here's the name field. So now here, this is a much more sophisticated graph than it used to be. And we're not quite done yet. Let's go ahead and change a few more things as we're making changes to our application. If I take a look at these people nodes, or person nodes, age, turns out, not really interested in that. It's not really a thing I care about anymore. I'd rather it just be removed from the graph. And this name field isn't quite right. It's just the first name, really. It's not their full name, so that field's a little vaguely named. I think I want to rename that. So let's go ahead and make those couple changes while we're messing around. So I'll pop back into VS Code. Those particular fields belong in this people pipeline. So I will go ahead and open that up. And making changes to the schema like this is actually really quite simple. We said we don't want age anymore, so I'll just go ahead and get rid of that line entirely. And now for this name field, let's go ahead and rename it to first name. Now, we also said to index that name, that old name field, so let's go ahead and also change that name to match. So let's think for a second about what this migration should look like. Well, first thing is it should say that it's going to remove that age property from the person nodes. We also want it to rename the name field to first name. And then we also wanted to kind of manage that index for us as well, because we want to no longer have an index on the age field, and instead have an index on the first name, or no longer have an index on the name field and instead have one on the first name field. So let's go ahead and generate a migration and see that that is what actually happens. So again, we'll do Nodestream migrations make. And instead of it just being automatically done, now it's asking us a question. And you might be like, well, why, right? Nodestream, with this kind of data, can't tell the difference between you renaming something and you deleting something and replacing it with something else. So it's thinking, did you rename age to first name? We didn't do that. We renamed name to first name. So I'm going to say no to this. And then it's like, oh, did you rename name to first name? And that we absolutely did. So let's go ahead and say yes to this. And that generated out a new migration file. The summary of those changes were that it dropped the property age, check. And it's renaming the property name to first name on the person node, check. And then it's dropping the old name index field and replacing that with a new first name index field, which is exactly what we wanted. So let's go ahead and run that migration. Let's run, target my database, and let's see that that actually worked. So how would we validate that? Let's go back up to our constraints. Nothing's really changed here because we didn't change any of this, right? We still have ID nodes, ID keys for both person and location, but we should see some changes in these indexes. Notably here, the first name index is indexing the first name field. There isn't one for a name field anymore, so we handled that. And then the last things we want to check out is, of course, the actual data. So let me go ahead and refresh our data. And if we take a look at the person nodes, we'll see the first name field as opposed to a name field. And no more age field on here, right? So that's all gone now. Again, there's still a lot of metadata in here that you didn't explicitly define because Nodestream tracks changes from the different pipelines. So you'll have a bunch of timestamps about the changes that pipelines make. And also our location nodes aren't changed, right? So we didn't do anything to change our location fields. Those are still the same. So it's able to really precisely change features in the graph. Under the hood, this isn't blowing away the graph and rebuilding it. It's actually making transactional changes to the database. So this is really good for applications where you don't need to worry about, where you can't not worry about uptime. So it's not an ephemeral graph kind of scenario. It's more for when you're actually building data and you need that to evolve over time in your database. So that's Nodestream schema awareness and how it can help you as a developer maintain the data. There's a couple cool little tidbits I want to throw in while we have a few minutes. Most notably is that you can actually take this and generate a GraphQL schema from it. So if we take a look at the Nodestream commands, Nodestream list, there's a print schema command. So if I run that, Nodestream print schema, it puts out in a very plain text format a summary of the main fields in our schema. But that's not super cool. But what if I do -- format GraphQL? This generates a GraphQL schema, which you can pipe out to a file if you want. Make that a little easier to see. And if I hop back to our project, open up that file, this schema is compatible with GraphQL, the GraphQL library from Neo4j. So you can basically stand up a GraphQL API just by copying this schema.graphql file into the boilerplate example of the GraphQL for Neo4j library. Fortunately, I didn't have time to set that particular feature up, but I did want to show it off that you can do that and just have an API that's automatically available to you. By default, it's excluding the non-read operations. It's just giving you a read API. Of course, you could change that if you wanted. because it's assuming that Nodestream is going to handle the writes in this particular case. Also, that plain text format is helpful too, just to kind of see what Nodestream thinks the schema is. And there's a option you can pass in here as well to override or augment the schema in any way that Nodestream doesn't automatically infer. And so that's all I had kind of prepared, and I think I'm ready to take some questions.